So here we have 4 different problems that deal with simplifying expressions with zero and negative exponents. So remember, for this, when we have zero exponents, what you do with that is, well, anything to the 0th power in math, we consider it to be equal to 1. For anything with a negative exponent, what you can do is you are able to move it. If it's in the numerator, you can move it to the denominator, and it will be equal to the positive form of that exponent. So, you will also be able to move it, if it's in the denominator, you move it to the numerator and change it to the positive form. Okay? So let's look at some of these examples. For number 1, we have 4a to the negative 3rd power over b to the 2nd power. Okay, so really what we need to do is we need to identify, are there any bases that have a negative exponent or 0 as an exponent? And we have one negative exponent here. So all we have to do is, well, we say 4. That has a positive exponent. That would just be 4 to the 1st power if we were to write one. Okay? A, that had a negative exponent, so it's going to move from the numerator to the denominator, and I'm simply going to write the positive form of that number. And then b was positive, so that remains where it was. So the answer to number 1 would be 4 over a to the 3rd power times b to the 2nd power. Usually when they're saying simplifying these expressions, what they're looking for, they are looking for simply positive exponents, right? So they don't want negative exponents, so that's how you're going to be simplifying. They could ask you to write this problem without fraction bars, right? Which would mean then everything would be in the numerator, and then you would have negative exponents. But for this one, simplifying it, we're removing any negative exponents. Number 2, all right, do we have any exponents of 0 or negative exponents? And the answer is yes. It's 3 to the 0th power, which is equal to 1, okay? Well, since any number times 1 is going to be that same number, I'm not going to write that in, okay? X to the 4th power, that's positive, so that remains in the numerator. Y to the negative 2nd, that means the y needs to go into my denominator. So it needs to be y to the positive 2nd, but I moved it from my numerator, and it's now in my denominator. Since it's z to the negative 3rd, I'm going to move that to the numerator, making it z to the positive 3rd. On number 3, again, we're just going to be simplifying. We need to identify, are there negative exponents or exponents of 0? And yes, I have 2 to the negative 2nd power, which means in my denominator I'm going to have 2 to the 2nd power. A to the 0th power, any number to the 0th power is the number 1, so I don't need to write that in. Over here, b to the 3rd, that's positive, so it remains in my numerator. C to the negative 2nd, well, since it's a negative exponent, I move it to my denominator, and I get c to the 2nd in my denominator. For 4, I look again, I see negative exponents. So I'm going to write in, alright, well, it's 2. Alright, and then I have x, okay? I'm going to have y to the negative 3rd, which means that's moving to my denominator. So it's going to become y to the positive 3rd in my denominator. Z to the negative 2nd, well, that needs to move to my numerator. It needs to be positive 2 now. And then I have 3 to the negative 1st power, so that 3 needs to come up. Now for this, we could use the commutative property to finish simplifying it, since I could rearrange this strand of multiplication problems, and I could get 2 times 3. Since they don't have exponents, I could simplify them, and it could become 6x z to the 2nd power over y to the 3rd. So there are a few more examples for you to work off of when you are dealing with simplifying expressions with 0 and negative exponents.